Hello everyone, this is Mrs. Descart, Assistant Professor of Mathematics, Arulmigu Palani and our Arts College for Women, Palani. Now let us going to discuss some problems on Descartes' rule of sign. So the first one is show that x power 7 minus 3x power 4 plus 2x cube minus 1 equal to 0 has at least 4 imaginary roots. That is, we have to show that this equation has at least 4 imaginary roots. So now let us consider the given equation as f of x equal to x power 7 minus 3x power 4 plus 2x cube minus 1 equal to 0. We know that the Descartes rule of sign. The first step is we have to write the signs of each terms from left to right. So the sign of x power 7 is positive, so now we are writing plus, and the next term is minus, and the next term will be plus, and the next term, last constant term, will have a negative sign, so it is minus. So if you have seen that the first sign is plus and the next sign is minus, so there is a change from the preceding term to the next term. It is positive to negative, so it is, now we will mark this as one change. Now the sign is minus and the next sign is positive, so we will have another change, so we will mark this as second change. And the next sign is plus, after that it is minus and there is another change, so we will mark this as change 3. So if we count the number of changes as plus 2 minus is one change, minus 2 plus is the second change, plus 2 minus is the third change. So there are 3 changes of signs. So by Descartes' rule of sign, f of x equal to 0 can have at most 3 positive roots. Now let us consider f of minus x. By replacing x by minus x, you will get f of minus x as x minus x power 7 minus 3x power 4 minus 2x cube minus 1 equal to 0. If we have write the sign of each term, so we will get the signs as minus, 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 minus. So there is no changes of sign. So hence f of x equal to 0 can have no negative real roots. So hence here alpha is the number of positive real roots, so we will have the value for alpha as 3, and beta is the number of negative real roots, so we will have here beta as 0. Hence f of x equal to 0 can have at most 3 real roots, that is alpha plus beta, 3 plus 0 is 3, so hence we have 3 real roots. Now the degree of the equation is 7, so n minus alpha plus beta gives 7 minus 3 plus 0, which implies 7 minus 3 equal to 4. Hence we are having 3 real roots and the degree of the equation is 7. By subtracting 7 and 3 we will get 4. Finally we conclude that there are 4 imaginary roots of f of x equal to 0. Hence f of x equal to 0 has at least 4 imaginary roots. And the second problem is prove that the equation x power 4 plus 3x minus 1 equal to 0 has 2 real and 2 imaginary roots. So now let us take in the signs of f of x as plus, plus, minus. So if you have seen, there is only one change, plus 2 minus of sign. So by Descartes' rule, f of x equal to 0 has at most one positive real root. And if you have taken f of minus x as x power 4 minus 3x minus 1, which is obtained by replacing x as minus x. Therefore the signs of the terms are plus, minus, minus. Here also we will have only one change of sign. Hence f of x equal to 0 has at most one negative real root. Therefore by adding these alpha and beta, that is alpha is the positive real root, number of positive real root, beta is the number of negative real root. Hence f of x equal to 0 has at most 2 real roots. Now From the given equation, the degree of f of x is equal to 0 is 4. By subtracting 4 minus 2, we will get the answer as 2. Hence f of x equal to 0 has at least 2 complex roots. Thank you.